So we are looking at graphing ratio relationships. Now, graphing a ratio relationship is a helpful way for us to visualize these ratios. And if we already have a ratio table like you can see here, then it's actually quite easy to graph that. So we've got, in this example, the ratio of flour in cups to water, also in cups. And you can see on our graph here, we have flour along the x-axis and water along the y-axis. And all we need to do is to plot these points. So we see when there are 4 cups of flour, there are 2 cups of water. So we can plot that point there. And then we can also see that when there are 8 cups of flour, there are 4 cups of water. So we would plot that point. And then when there are 12 cups of flour, there are 6 cups of water. So we can plot that. And the last step is just to connect these dots by drawing a line through it. And this would be the graph of our ratio. Now you could also see that this graph and the line provides us with the ability to see more than just these 3 points that we have. So for example, I can see that if I have 2 cups of flour, then I would have 1 cup of water. Or if I had 14 cups of flour, you can see that I would have 7 cups of water. Let's look at another example. So for the second one, we've got time in hours and earnings in dollars. So we've got for 1 hour you earn $10, 2 hours you earn $20, and 3 hours you earn $30. So if we look at our graph here, we can go ahead and plot those points. So we're going to find 1 on the x-axis for time and 10 on the y-axis for dollars, and we can plot that point. We'll do the same thing for 2 and 20, and 3 hours and $30. So we've plotted our points, we can draw the line, and we're done there. Now let's also look at an example of how we could use this information to help us. So first, again, we will go ahead and graph this. So this problem says you buy dark chocolate cashews for $12.50 per pound. So the first thing we'd want to do is to make our ratio table that will help us plot our points here. So we know that for every 1 pound, it's going to be $12.50. So if we were to do pounds, we've got 1 and $12.50, or 12.5. 2, we would have 2 times 12.5, which is 25. And for 3 pounds, 3 times 12.5, we'd have 37.5. So then we could plot these points on our graph. We've got 1, and we can put 12.5 here, halfway between 10 and 15. We can put 2 and 25, and 3 and 37.5. Again, we could connect the dots there and draw our graph. Now, using this graph, we could answer this question. How much does 2.5 pounds of dark chocolate cashews cost? Well, we can see on our graph, we're going to find 2.5 pounds of cashews, which would be right here. And if we follow that up, we'll see that it looks to be between 30 and 35, definitely, maybe slightly less than half. So I might say $32 there. And as we're looking and connecting these dots, obviously we wouldn't be able to do that exact amount just looking at the graph, but we could also do the multiplication here, 2.5 times 12.5. One more example here. A hot air balloon rises 9 meters every 3 seconds. A blimp rises 7 meters every 2 seconds. Graph each ratio relationship in the same coordinate plane. Which rises faster? So this time we're going to set up our coordinate plane and create our ratio tables, and then we'll be able to graph each of them to see which one is rising at a faster rate. So for the balloon, we know it's going 9 meters every 3 seconds. So time here, we could have 3 with a height of 9, and then 6 with a height of 18, and 9 with a height of 27. For the blimp, rising 7 meters every 2 seconds, we could have 2 and 7, 4 and 14, and 6 and 21. So we can now use that to graph in the coordinate plane. So for the balloon, we'll have a point at 3 and 9, 6 and 18, and 9 and 27. So we plot those points and draw a line through it. And we can do the same for the blimp. So we'll have one at 2, 7, 4, 14, and 6, 21. And we'll draw our line there. Now, we can look at these graphs here and determine which one is rising faster. So you'll notice the blue line is higher than the red line, and if they were to continue, it would get, the difference between these would be larger over time because the height is increasing faster over time for the blimp than it is for the balloon. So we could use that to answer this question here.